Welcome to Pre-Calculus. Today we will investigate finding trigonometric ratios given right triangles. We'll take a look at three examples. My first example is asking for us to find the value of the trig function indicated. And the one that we are looking at for this first example is finding sine of theta. So first of all, we got to investigate this right triangle. And in order to find really any type trigonometric ratio, I need to have the side lengths. So looking at this right triangle, I've got two of the side lengths. The leg here on the lower side is 4 in length, and the hypotenuse, which is opposite the right angle, has a length of 5. So in order for me to really catch what the value of sine of theta is, I need that third side. So before I can actually come up with the value of the trigonometric ratio, I need to use the Pythagorean theorem to find the missing side here. So just to remind about Pythagorean theorem, that's a squared plus b squared equals c squared. So I want to label these sides. And in fact, the way I'm going to start is by labeling the vertices. The two vertices that are at the acute angles in the right triangle, I can label A and B. Those are interchangeable. The angle that has to be labeled C is the right angle. Now, the reason for that is because the side opposite from the vertex shares the same label. So the side opposite C is lowercase c, and that's the hypotenuse. That has to be my C in the Pythagorean theorem. I'll label the other two. If my vertex A is on the left, the side opposite with length of 4 is side A. And the side that we need to find opposite of vertex B is side B. So that tells me the values that I need to substitute in Pythagorean theorem. I'm going to substitute 4 for A, so 4 squared, plus B squared. So I'm just going to emphasize that we're trying to solve for B there, equals C, or 5 substituted in squared. Then I want to solve for B. So I'm going to go ahead and square these values. 4 squared is 16. 5 squared is 25. So to solve for B, what we need to do initially is subtract this 16 from both sides. So we'll do that. 16 will cancel from the left. And on the right, we've got 25 minus 16, and that's going to give us 9. So we have now that B squared equals 9. And I'm not really interested in B squared. I want just the value of B really to the first power. So I'm going to take the square root, and that immediately solves for me the side length of B as having a length of 3. So I'm going to go ahead and label that missing side here. Now, we did that so that I could calculate the value of sine of theta. So we'll start with sine. In fact, for this example, let's calculate all 6 trigonometric ratios. So I'm going to start with sine. It's abbreviated here SIN. The full spelling of sine is SINE. But we'll go with the abbreviation. Sine of theta is given as a ratio of 2 side lengths. Now, I need to go back to the diagram to determine which of these side lengths are which in relation to theta. And what that means is really just where are they with respect to theta. So I'm going to start with theta here. The side that's always the same is this hypotenuse. So I'm going to label it hypotenuse. And then the two legs, I'm going to distinguish from one another with how they relate to this angle theta. Side B, we would say, is opposite theta. So I'm going to label that opposite. And that's distinct from side A, which we would say is adjacent to theta. And that word adjacent really just means next to. You can think the side that's adjacent, it actually forms one of the sides that makes the angle itself. Well, we label those sides like that so that I can calculate these trigonometric ratios. So sine of theta, the way that we define it is that it's the length of the opposite side divided by the hypotenuse. So now that I have all three side lengths, I just need to grab those dimensions. So the side opposite, that's the one we just solved for, is 3. And the hypotenuse is 5. And immediately we see sine of theta here has a value of 3/5, 3/5. Let's calculate the other trigonometric ratios. So there are 3 that are considered, in a way, basic trigonometric functions. So sine is one of them. Another one of those is cosine. Full spelling of cosine is C-O-S-I-N-E, but it also is abbreviated as C-O-S. Now, the way we define cosine is as the adjacent side divided by the hypotenuse. Now, once I've got all 3 sides of the triangles, I can calculate cosine as well. So I'm just going to grab the length of the adjacent side, that's 4, over the hypotenuse, which is still 5. So the value of cosine here is 4/5. The third basic trigonometric ratio is tangent. So let's define tangent. Tangent is fully spelled T-A-N-G-E-N-T. It's also abbreviated as TAN, tangent of theta. And tangent's unique among the basic ones because it does not involve the hypotenuse. The way we define tangent is as the opposite side divided by the adjacent side. So tangent really only involves the 2 leg lengths. So for this right triangle here in our first example, it's going to be 3 divided by the adjacent side length 4. Tangent has a value of 3/4. Now, those are the basic trigonometric ratios. We also have 3 that are related to those basic ones, and they're just the reciprocals. So let's start and just real quickly define those. The one that's related to sine is going to be cosecant. So we'll spell it fully out there, cosecant. And the way we would abbreviate cosecant is CSC of theta. Now, let's define it. So we've already said that cosecant is the reciprocal of sine. So that just means take the fraction and flip it over. So it's going to be defined as hypotenuse, which you'll notice was in the denominator of sine. In the cosecant, it's in the numerator. And then in the denominator of cosecant, we've got opposite. So when I go to calculate cosecant, it's really just the value of sine flipped over. Sine here was 3/5. Cosecant is going to be 5/3. The other 2 related trigonometric ratios follow that same pattern. So for cosine, its reciprocal is going to be secant. So we spell secant, S-E-C-A-N-T. We abbreviate it SEC, like second of theta, but it's secant. And again, it's the same relationship that sine and cosecant share. Secant is the reciprocal of cosine. So it's going to be defined as hypotenuse over adjacent. And it's very easy to calculate once we've got cosine's value. If cosine's 4/5, secant is going to be 5/4. And then our final trigonometric ratio is the reciprocal of tangent. That's going to be cotangent. So again, it's got a full spelling that we often abbreviate as COT, cotangent. And just like cosecant and secant, cotangent is the reciprocal of tangent. So we would define it as adjacent over opposite. So that if tangent has a value like we've calculated here of 3 over 4, cotangent will have the value of 4 over 3. So we've done more than we need to do here for this question. Really, all we were trying to do was define sine. But in truth, once I've got the 3 side lengths of any right triangle, I can find all 6. Our second example gives us a written description of a triangle, and again asks us to find one of these 6 ratios. Here we're looking for cosecant of angle A if side length B is 12 and side length C is 20. I always start off by drawing a diagram. So I'm going to draw a right triangle, and I don't really know if it's to scale. But what I need to do is label it, because really it's up to matching the pieces of this diagram with the information that I'm given in the words. I'm going to start by marking my right angle and labeling that C, which means my other 2 vertices are going to be A and B. A and B I could have switched. The only one that's got to be C is the right angle. And then I'm going to identify the side. So opposite vertex C is side C, and we have that it's got a length of 20. Opposite A is side A, and that we don't know. Opposite side or vertex B is side B, and that has a length of 12. So I'm going to locate angle A. That's up here in the upper left. And we are trying to calculate cosecant. So cosecant, just to remember how we defined it in our first example, is going to be given as, it's again the reciprocal of sine. So sine was opposite over hypotenuse. So cosecant is going to be hypotenuse over opposite. So I want to check to see if I've got those pieces here in this right triangle. I have the hypotenuse. Again, that's always side C. So I've got that value, but I do not have the length of the opposite side, side A. So I need to use Pythagorean theorem to come up with that measurement. So we'll set it up again. We're looking for the length of side A. So A squared plus B squared. I'm going to go ahead and fill in the values. B is given as 12, so 12 squared equals C squared. C is given as side length of 20 squared. So again, we need to solve this out. So A squared, I'm going to square these values. 12 squared is 144. And 20 squared is going to give us 400. And then I want to solve for A. Subtract 144. It'll cancel on the left. Subtract 144 from 400. So at this point, we've got just A squared on the left equals, if we subtract 400 minus 144, let's go ahead and calculate that. That's going to be a 6, a 5, and a 2, 256. But again, I don't really want just A squared. I want only A. So I want to take the square root of both sides. And that gives me A equals square root of 256, which I believe is 16. Let's just check. 16 times 16. So 6 times 6 is 36. 6 times 1, 6 plus 3 is 9. 0, and then 1, 60. And yes, indeed, 256 is 16 times 16. So its square root is going to be just 16. And I'll go ahead and place that on our diagram. Once I've got that side length, I'm ready to calculate cosecant. So it's hypotenuse 20 divided by side length opposite of angle A, which is going to have the length of 16, the one we just calculated. And then I can reduce 20 divided by 16. I can divide out 4 from both. And that's going to give me a ratio of 5:4. Our third example is asking us to find a trigonometric ratio, cotangent, if I know that sine of theta is 3 times the square root of 10 over 10. So here I have different information, but even so, I'm going to start again with a diagram of a right triangle. So we'll just draw a right triangle. Again, I don't know if it's exactly to scale. And let's label these side lengths. So again, the one that I start with always is vertex C. That's my right angle. And then I'll just call the acute angles A and B. And let's just locate where we're saying theta is. So let's just call theta here angle A. So I'm going to use this ratio for sine. And what I need to remember is how we would have calculated it. Sine is opposite over hypotenuse. So what I want to do initially is I just want to identify that my opposite side should have a length of 3 squared root of 10, whatever's in the numerator. And the hypotenuse should have the length of 10, whatever's in the denominator. So I'm going to label those sides with those lengths. So the side opposite theta in my right triangle is going to be side BC. I'm going to call that side A, and it has a value of 3 times the square root of 10. Hypotenuse has to be C, so I'll call that side length of 10. And again, I need to think about how to calculate cotangent now. So I used the trigonometric ratio that's given to find 2 of the side lengths. Let's see if I need that missing side, side B. So I just need to remember how to calculate cotangent. That's what I'm looking for here. Cotangent of theta, it's the reciprocal of tangent. Tangent was opposite over adjacent, so cotangent is going to be adjacent over opposite. So looking at my triangle, I definitely have the opposite side length. That's 3 square root of 10, but I do not yet have the adjacent side length, side B. So just like in my first 2 examples, I've got to use Pythagorean theorem in order to find that missing side length. So we'll set it up again. It's a squared plus b squared, so 3 square root of 10. That's side length A squared plus B, what I'm looking for, squared, equals C, or 10 squared. So just as in our previous examples, I'm going to start the solution for B by squaring these values. So 3 times the square root of 10 is going to be 9 times just 10, or 90, plus B squared equals 10 squared is going to be 100. And at that point, I'm ready to subtract 90 over. It'll cancel on the left, and we'll subtract it from 100 to get B squared equals 10. And I'm going to take the square root because I'm really interested in just B, not really in B squared. And that's going to give me a value of B equals the square root of 10. So I'm going to go ahead and label that side length. Once I've got the side lengths, now I'm ready to calculate cotangent. So we'd already defined it. It's adjacent over opposite. So it's going to be the square root of 10. That's my adjacent side length here at B, divided by the opposite side length, which is 3 times the square root of 10. And I've got my ratio. All I got to do is reduce. So I see I have a square root of 10 above and below. It'll cancel by division. And the ultimate value of cotangent of theta here is going to be 1 over 3. Thank you for joining for this investigation of finding sine, cosine, tangent, cosecant, secant, and cotangent. See you soon.